We are now going to study place value systems. So our familiar Hindu-Arabic numeration system is an example of a place value system, and the reason is that if I write the number 5,821, this is the ones place, this is the tens place, this is the hundreds place, and this is the thousands place. So what exactly does that mean? So that means that this number, the 5 here, is not simply equal to 5. Because of the placement, it's actually equal to 5,000. And the 8 here is corresponds to 800, and because of the placement of the 2 in the tens place, we know that corresponds to 20. And then in the ones place, we have 1. And I'm going to break this down even further. 5,000 is 5 times 1,000. And 800 is 8 times 100. And then we have 2 times 10. And we have 1 times 1. And the numbers, note that we are using powers of 10 for our place values. Okay, so this is what we call a base 10 system. Okay, because all of our numbers are formed using powers of 10. And we call this form when we write everything out like this, the expanded form. Okay, so these are all expanded forms. A second example of a place value numeration system is the Babylonian numeration system. And this is essentially like a base 60 numeration system. So the first thing that we will learn is how to write numbers 1 through 60 in this numeration system. So any number 1 through 60 is written using 2 symbols. The first symbol looks like a stake, and this represents 1. And the second symbol looks a little bit like a sideways V or a boomerang. And this represents 10. So basically, if you wanted to write the number 23, you would need 2 of the 10s. And then you would need 3 of the stake-like figures. And this would give us the number 23. In order to express numbers that are greater than 60, a place value system is used. So I'm going to illustrate the place value system using an example. And so if you look at this Babylonian number, the symbols are grouped into 4 groups. So there's the rightmost group here. And then I see a second group here, a third group, and a fourth group. So we know that this number here in Babylonian represents 2. This is 10. This is 10 plus 1. So this is the additive part. It's 11. And this part over here is again 2. So the way the place value works is that the number, the grouping that is on rightmost corresponds to the place value of 60 to the 0th power. So that's just 1. And then the next, the second to the right corresponds to the place value 60 to the first power, which is just 60, and then we have 60 squared and 60 cubed. So these are like the place, and etc. These are the place values. So just as we did for the Hindu-Arabic system, we're going to combine the place value with the numeral that we see written in that place value. So the value of this number is going to be 2 times 60 cubed plus 11 times 60 squared plus 10 times 60 to the first power plus 2 times 60 to 0th power. So this is going to give us 432,000 plus 39,600 plus 600 plus 2. Okay, and our final number is 400 in Hindu Arabic is 472,202. So if you want to write 472,202 in Babylonian, this is how you would write it. Okay, so let's do an example here. Let's write Hindu Arabic 8,350 in Babylonian, and we're going to remember that in Babylonian the little sideways V or boomerang is for 10. The stake-like figure was used for 1, and recall that it's a place value system, so the rightmost digit corresponds to grouping corresponds to 1. The next grouping corresponded to 60. The next grouping corresponded to 3,600, 60 squared. And the next grouping corresponded to 60 cubed. So if we want to write 8,350 using Babylonian, we have to think about how many groupings first and foremost of 3,600 fit into 8,350. So I'm going to use long division, and I'm going to divide 3,600 into 8,350. So I know that that goes in 2 times, and 2 times 3,600 is 7,200, and then using long division I just subtract, and I'm left with 1150. I know 3,600 does not go into 1150, so we're pretty much done. There's 2 groups of 3,600 that will fit into 8,350. Now I'm going to take the remainder, which is 1,150, and I'm going to see how many groups of 60 fit into the remainder. So using the division, long division, 60 doesn't go into 1 or 11, but it does go into 115 once. So I am going to, I multiply, I subtract, and I bring down the 0. How many times does 60 go into 550? That's 9 times. 9 times 60 will give me 540. So my remainder is 10. Okay, and we know that 1 will go into 10 times. So the result of this process is it's telling me that 8,350 is equal to 2 times 3,600 plus 19 times 60 plus 10 times 1. So writing that using our place values, that's 2 times 60 squared plus 19 times 60 to the first power plus 10 times 60 to the 0th power. So these are going to give us our 3 groupings in Babylonian. So in the rightmost grouping, I'm going to need 10 copies of 1. So I'm just going to write my first grouping, and then that's the first grouping. And for the second grouping, we need 19. Okay, so the second from the right. I'm going to start with a 10, and I'm going to make 9 stakes. So there's 1, 2, 3. And for the third grouping, I need 2, which is just going to be 2 stakes. Okay, so those are our 3 groupings. So those are the 3 groupings, and this is how you would write 8,350 in Babylonian. So the last numeration system that uses place value that we are going to look at is the Mayan numeration system. And in this system, the numbers 1 through 20 are written as follows. So basically, bars are used to denote 5, and then dots are used to denote like 1. So if you wanted to say write the number 12, you would need 2 bars, so that's 2 times 5, and then you would need 2 dots. And so that's why you see the 12 right here. To write numbers greater than 20, we're going to use a place value system. It's a little different compared to the base 10 and the base 60. The bases are a little more complicated, and they're going to be stacked vertically, but it's basically the same idea. So in the very bottom of the stack, we're going to have the place value for 20 to the 0, so that's the ones place. And then above that, we're going to have the place value corresponding to 20 to the first power. And then here's where things get a little tricky. It's based off the Mayan calendar, but the next place value is 18 times 20 to the first power, so that's 360. And then we have 18 times 20 to the second power. That's the place value. So that corresponds to 7,200 and so on. So then we have 18 times 20 cubed, and that corresponds to 144,000. Okay, etc. And it keeps going. ... So here's a quick example. Here we see a Mayan numeral, okay, and we want to know what is this equal to in Hindu Arabic. So we see 3 different symbols stacked vertically. So remember that this symbol right here is 5 plus 5 plus 1, so this is 11, and it is in the place value it is in the bottom place value, so this is times 20 to the 0, or just 1. So the value here is 11. If we go to the second symbol, this is 8. Okay, using, we're up here. And the place value here is 20 to the first power, so this is 160. And if we go to the third numeral in the stacking, we see that this is equal to 10. So we have 10 times, and the place value is 360, so that would be 3,600. So this number is equal to 3,600 plus 160 plus 11, so this is 3,771. Okay, so the Hindu Arabic 3,771 can be written like this in Mayan numerals. Let's do one more example. We are going to write the Hindu Arabic number 10,231 as a Mayan numeral. And so let's start by remembering that the Mayan numerals 1 through 20 are written like this, and or 1 through 19. And let's also remember that these numerals are going to be stacked vertically. So the place values, we have the bottom, and then we start stacking vertically. So in this case, if I look at this number, it looks like the largest number that divides into it is 7,200. So we're going to start with long division again. So how many times does 7,200 go into 231? I think we can all see it only goes in once. So then I subtract. Okay, and then the next question is, okay, so we've taken care of this guy. How many times does 360, how many groups of 360 go into the remainder here, which is 3,031? So let's check that out. And it looks like 3,000, well, 10 times 360 is 3,600, so that's too much. So let's try out 360 times 8 and see if that works. So I'm going to use 8. I multiply by 8, I get 2,880. I subtract. And what I'm left with is 151. Okay, so now I have 151, and I need to see how many groups of 20 are going to go in there. So 151, let's see, and I think we can see that 20 doesn't go into 1 or 15, but it's going to go in 7 times. So I multiply, I subtract, and then there's just a remainder of 11 left. So basically what these divisions tell me is that 10,231 is equal to 1 times 7,200 plus 8 times 360 plus 7 times 20 plus 11 times 1. Okay, so we're going to have a stack here that's going to have 4 different things in it. So I'm going to start with the smallest, the bottom. How are we going to express 11 in Mayan? So remember, I have 5 plus 5 plus 1. So that's my first grouping. So let's move to the next place value up. Okay, and I need 7 copies of 20. So 1 bar, that's 5, 6, 7. And then I'm going to move on to the next place value. So we have 8 times 360. So in this case, 8 is expressed as 5, 6, 7, 8. And I'm finally going to move on to 1 times 7,200. And 1 is just expressed as a single dot. Okay, and so this is Mayan for 10,231.